Hey guys, I'm going to teach you how to write equations from tables and graphs. By the end of this lesson, you'll be able to write equations in slope-intercept form using multiple different representations. So go ahead and get your binder, turn to the math section, let's go ahead and take some notes. Okay, a couple things to know here. The equation of a linear function is y equals mx plus b. That's called slope-intercept form. It's called slope-intercept form because you have to have two things to write it. You have to have the slope and you have to have the y-intercept. Your slope and y-intercept are both numbers. Once you know those numbers, you're going to plug them into this equation. The slope goes in for the m. It's how you move on the graph. It's the multiplier. So it goes right there next to the x. That's where the slope is. B is the y-intercept. It's where your line begins on the y-axis. So when we have those two values, we write them in this form. The x and y stay variables because those represent the points on our graph. So we need our equation written in slope-intercept form, but sometimes we're not just given the slope and the y-intercept. We have to find it. If we're given just a table, we're going to pull out the slope by picking 2 points and then plugging them into our slope formula. Y minus y over x minus x. That'll give us the slope, which we have to write our equation. The next thing we're going to do is look for the y-intercept. We might be able to see it because it might be a point in the table. If the x value is 0, that's where our y-intercept is. So I put that as a b because that's going to be our number. It's going to go in for our y-intercept if that point is in the table. When we want to write an equation from a graph, we still need the slope and the y-intercept. From a graph, we can count the slope by setting up a ratio of rise over run. We're going to count up and over from point to point and see how they connect. The next thing we can do is look for the y-intercept, and that's the point where the graph crosses the y-axis. We're going to look at 4 different real-life examples today, and I'm going to do the first one kind of with you, and you're going to do the next one all by yourself. So make sure you're paying attention. Luke's family goes to the movies and purchases a large popcorn. They do that right away before they do anything else. Then they're going to decide whether or not they want to purchase any drinks. This is the table that shows how much they'll spend based on the number of drinks they'll decide to purchase. So let's go ahead and start. Let's label what our x and our y is in this function. The input is the number of drinks. Your cost is the output. It depends on the number of drinks that you buy. And it might be easier to start by looking at this first point here. After 0 drinks, they've spent $6.25. How is that possible and what does that represent? Remember, we're looking at this point in the table whenever the x is 0 for what the y is. That's always going to be our y-intercept in the table. And in this case, that's the price of the popcorn because right away they purchased that popcorn without ever buying a drink. So we have the y-intercept. We know what they began spending, but we don't know the slope. We don't know the rate, but we should know how to find it. When we're given a table, how can we find the slope? We're going to pick any 2 points in the table and we're going to do our slope formula. Y minus y over the x minus the x. So I'm just going to start by picking 10 minus the other y over the x that goes with the 10 minus the other x. Using this formula, what is the slope? The slope is 375. Now what does that slope or rate of change represent in this situation? 375 is the dollar amount. It costs $3.75 per drink. That's because they started at $6.25 not buying a drink. Then they spent $3.75 more and now they spent $10. Go up again, $3.75. And that's the constant rate that it increases each time. That means that each drink costs $3.75. All right, now that we have our slope, now that we have our y-intercept, we have the 2 key pieces of information to write our equation in slope-intercept form. Go ahead and put those values into the equation. Pause the video now to do that, and then press play when you're ready to check. All right, here's how I would have written it. Y equals 3.75x plus 625. Here's an alternative way you could have written it, and I just want to show you this because it's the same thing. It's just written backwards. The y-intercept is the beginning point, so you can begin with that as long as it's the number that's by itself. The 375 is the multiplier. As long as it's attached to the x, that's okay. And then that can equal y on the other side. It's still a function, it's still linear, and it's still written in slope-intercept form. All right, so using all of that as an example, let's skip down to number 3, and I want you to start by looking at this example about a plane using amount of fuel based on the number of miles it travels, and I want you to start by telling me what is the y-intercept and what does it represent. All right, we can see the y-intercept is right here at the 0, 0 point. Miles are the x, gallons of fuel is the y. So if the plane uses 0 gallons of fuel, obviously the plane can't move. It has to travel 0 miles. So we know we need the y-intercept. We also know we need the slope. Go ahead and find the slope from this table using the slope formula and press play when you're ready to check. All right, if I use my slope formula, I would do 156 minus 0, which is 156, divided by 30 minus 0, which is 30. So 156 divided by 30 is what I'm left with. That's 5.2. You should also realize since this relationship is proportional, you can just go ahead and do y divided by x. And for every point in this table, whichever point you chose, you would end up with a constant rate of 5.2. So in this situation, what does that 5.2 represent? we did y divided by x, or gallons per mile. So if we got 5.2, that's how many gallons are used per 1 mile. So 5.2 is the slope, or the constant rate of change for this function. Now go ahead and finish this out by writing this whole thing as an equation. Go ahead and pause the video now and press play when you're ready to check. Alright, in slope-intercept form, you could have written y equals 5.2x. You could have also written y equals 5.2x plus 0. Either one is fine. And that's it. Now let's go back up and look at number 2 together again. This time we're trying to write an equation in slope-intercept form for this graph. This graph is showing the relationship between the amount of brown sugar and butter that's used in a chocolate chip cookie recipe. We need to go ahead and start by finding the y-intercept for this graph. Go ahead and tell me, where does this line cross on the y-axis? This line crosses at 0, so the y-intercept is 0. The next thing we can go ahead and find is the slope by counting the rise over the run. I can go ahead and tell you counting up 3 over 4 for each one of these points is going to get us from point to point. So 3 to 4, or 3/4 is our slope. Now let's go ahead and write that as an equation in slope-intercept form. I've got y equals 3/4 x. You could have also written y equals 3/4 x plus 0. But we know that 3/4 is the slope. It has to be the number that's right there being multiplied by the x. Now let's go ahead and figure out, what does the slope and the y-intercept represent in this situation. Alright, so obviously to start, if you've not cooked anything, if you've not made any cookies, you're at 0, 0. 0 cups of butter for 0 cups of brown sugar. We can also say that the recipe uses 3 cups of brown sugar for every 4 cups of butter. Or in other words, 3/4 of a cup of brown sugar for every 1 cup of butter. And that's how we wrote an equation for this graph, and that's what it means. So let's go ahead and look at this last example. This one's going to be one you're going to do more by yourself. So let's pay attention and make sure you're doing this. It says Robert pays for his family to go bowling. He's going to first rent shoes for everybody. Then he's going to pay a certain amount per game that his family plays. And that's shown right here in the graph. So it might be easier to start with the y-intercept. What is it and what does it mean? The y-intercept is 12. We know that the y-axis represents cost, and we know that he started out by buying shoes. The key word is first, or starts, or begins. That's going to be the b in our equation. Now we're going to find the slope from the graph, and we're going to do that by counting from point to point. You want to count your rise over your run. I will caution you, pay close attention to the scale on the y-axis. It's going up by 3s each time. So when you count from 12 to 15, don't just count 1, count 3, 6, 9, and so on. Go ahead and try this now by yourself, and then press play when you're ready to check. Alright, if you count up 9 over 2 for each one of these, you can write that as a ratio. 9 divided by 2 comes out to be 4.5. That's our slope. You can write it as 9 over 2 or 4.5. 4.5 makes more sense in this situation because in this case, the slope represents the cost per game. Last thing, go ahead and finish this out by writing the equation for this function in slope-intercept form. Alright, you should have y equals 4.5x plus 12. You could also write it as 12 plus 4.5x because that's what it costs per game. Go ahead and take 1 to 2 sentences to summarize today's lesson. How do we write an equation from a graph or a table? Alright guys, that's it. If you made it to the end of this video, I want to know, if you could transform into any fictional character for a day, who would it be and why? Today we learned about how to write equations from graphs and tables. So now you should be able to write equations in slope-intercept form using those multiple representations. Now you should go ahead and go back to the calendar and complete any other assignments you have left for the day. If you have any questions, bye!